Welcome back to SpatialNnachi GIS Series. In our previous class, we explored coordinate systems and map projections, which help us understand how GIS accurately represents locations on Earth. Today, we'll build on that knowledge by learning two very important practical GIS skills, georeferencing and digitization. By the end of this lesson, you will know how to align a map correctly and convert it into usable GIS data. Let's begin. What is georeferencing? Georeferencing is simply the process of assigning real-world coordinates to an image or map. A scanned paper map, a JPEG image, or satellite screenshot may look like a map, but ArcGIS does not know where it belongs on Earth until we georeference it. So georeference tells ArcMap exactly where to place that image in geographic space. Think of it like placing a photograph onto a real-world coordinate grid so it fits accurately with other spatial data sets. Now, why is georeferencing important? Without georeferencing, your map cannot align correctly with other GIS layers. This means analysis would be inaccurate and digitized features would not reflect their true location. Proper georeferencing ensures spatial accuracy. So you add our map and your project, click and add it. And this is our JPEG image. This was the map that we created in our last series modules. Now, we have our map here, and it is very important for us to understand where the grid meets because it is the intersection between the longitude and the latitude that we are going to be picking to be able to give us our nothing and our instance. Let's go ahead and add the referencing tool because it's not here. So if you right click on this toolbox, any tools that you're looking for and you don't see within this interface, right click here and you will see them here depending on what you're looking for. And once you check the box, it's going to appear. And this is georeference as it is here. And the project that we want to georeference is Nigerian map because you could have more than one images imported on your ArcGIS interface. So what we'll be doing quickly is to zoom into this place because that's where we'll be taking our coordinates from. And there you go. We have our latitude and our longitude. So when you come to this particular page, you see add control points. What you do is that you click. Let me see, there's already a coordinate point there. Let me be sure. Okay, I had already done this before. So let me delete it totally so that we start afresh. We'll come to map extent, zoom. I hope you're seeing how I'm utilizing the toolbox to get what it is I'm looking for per time. The reason why we're zooming is because you need to come very close so that your point doesn't shake. Because if you just georeference at this point, if you zoom in, you may realize that your point is here, while the intersection is here. So zooming in gives us more details to what we're looking for. And add control point, you keep it here, left click and right click. It tells you impute X and Y, and there you go. So these are your coordinates now. It is important for us to understand what X means and what Y means, even if we don't see latitude or longitude. So X, which is this, is a line of latitude, and it measures distance from north to south of the equator. While Y, which is this, is a line of longitude, which measures distance east and west of the prime meridian. It's very important because once you interchange these two, your map is going to be distorted, which is what we are going to do first, so that you see the distortion of map and what it looks like. So since you know X is our latitude, we will not be picking this. Instead, we'll be picking longitude just to show you what the distortion of map can look like. And we'll be fixing 11.399365 as our latitude, and our longitude will be putting 6.170588. And we are pressing OK. That's our first point. You zoom in again, you see your first point will not show anything. It's until you align it with another point before you get the full story if your digitization is correct or not. We add another control point, come here, left click and right click, impute X and Y. Remember that we put 11 as our longitude, 11.399365, and then Y as 8.950980. And you do this. Now, Our map has disappeared. See what happens. This is what distortion looks like. What this simply means is that the coordinates that you imputed was mismatched. Where you were supposed to put X, you put Y, and where you were supposed to put Y, you put X, and this is what you get. This is a very common mistake with beginners, and I just needed to do it so that we tend to see it. So once this happens, you just need to go back, delete this coordinates, and start all over again to verify it. So yeah, I'll be fast now. Update the reference. And once we updated that, is already stored um, in the table. Yeah. So the next we'll be doing is um, digitization. We've added our control points. Control points connect known location on the scanned image to their true locations on the reference layers, which is just what we did. And the more accurate and well distributed your control points, the better your georeferencing results. Um, one very important tip is that you should avoid clustering all points in one area. That is why I used this point, this point, this point, and this point for our georeferencing. I expanded my points for georeferencing. Now, the link table shows coordinate relationship and residual error. This is the link table. If you view link table, you will see certain things here, the X, the Y, then see the residual. Residual error tells us how accurate our alignment is. So lower values indicate better accuracy. And like you see, we have 0.0000.000 as our residual. Our total residual is 0.0007. It is a very low value. And high residual value suggests poor control point placement. So this shows that our control point was placed accurately. This teaches correction. So I hope you've understood how we georeference a map. It's really not difficult. So the image is now spatially aware. Next, what is digitization? Now that our image is accurately positioned, we can digitize. Digitization is the process of converting map features into digital GIS data. The feature types we have is points, lines, and polygons. Points represent schools, borehole, hospitals. Line represents road, rivers, pipelines. Polygons represent state boundaries, land parcels, or a bigger expanse of water bodies. So these are the features that we use to represent features on the ground on the map, if you understand what I mean. But for this particular georeferencing exercise and digitization exercise, what we have here is only polygon. And like you see, this is our state boundaries of Kaduna, and that is just what we want to digitize. We will not be digitizing all of them. We will just be working with either one or two of the local government as an area of interest. You could replicate it by digitizing the whole of Kaduna if you so wish, but it's the same process that we do. So first thing we need to do is to create a shapefile. And how to create a shapefile is by going to catalog. If you have where you work, this is where I do my work. If you click on it, you see different shapefiles I have here already. How to create a new shapefile is by clicking here, new. You see, there are folders, there are geodatabase, there are other file formats that are here. But shapefile is what we're looking for because that stores vector images. Shapefile stores vector data. So we click on shapefile. Now, new shapefile, we put the name of what we want here, what we want to digitize. Kaduna, in our case, Kaduna LGA underscore map. So we use underscore because that's the right way to label instead of space. We use underscore. So the feature type, this is what I explained to you. We have point, line, and polygon as the features that we use to represent other features or physical features on the Earth surface. So because what we are dealing with is more of a boundary, we'll take polygon. And if you look here, you realize that unknown coordinate system for this feature that we want to create, for this shapefile that we want to create. So what we do is that we look for coordinate system. Now, I would like to express that by default, whenever you georeference, the default coordinate system that comes with it is a geographic coordinate system. So if I want to go ahead and use a projected coordinate system, I would have trouble here because there will be a mismatch. So I want us to understand that by default, whenever we digitize georeference a map, it comes as geographic coordinate system. Then if we want to do certain calculations, because geographic coordinate system is not necessarily good in calculation because the unit is in angular degrees, the angular unit is in degrees, and we'll just go to our toolbox and go and project, change the coordinate system to something else before we can do accurate measurement in meters, which will show distance, area, and other measurements. So we go to geographic. What do we have? I think we have world. We have WGS 1984. We have achieved this. We go to OK, and then we have it. So what we've done now basically is that we have created a shapefile for this particular world, and we've been able to get Kaduna local government map. It's already here. Immediately we created the shapefile. It appeared here. So what we'll be doing next is to start digitizing. So from this map, I just want us to take to digitize 3 places, which is Benin, Gwari, Chukun, and Giwa. Yes, so that's what we'll be digitizing. Now we'll start editing. We come to that particular shapefile I want to edit, I want to create, and click on it. And then come to create feature. Going to be here is in polygon. If it doesn't point, you will see point, and if it doesn't line, you will see line. So once you start editing, you have to go and click on that feature that you want to edit. If you had lines, it would appear. If you had points, it would appear. So once you click on it, it's the digitizing tool comes automatically on. So while you digitize, you click on it and you trace. Digitizing actually means tracing. So you trace it once. If you zoom in, you get a clearer picture of what you're doing. Now, this is just an example. Digitization, you have to be much more careful. So once you get all this, if I let me even show you how it's done, ideally, so that you get them. So you realize that in this, because of the way we've been digitizing, you will see that there are even some mistakes. I'm not following the line. And you realize that when you zoom in more, you tend to see where you place your lines inside the boundary that you want to digitize. So it's easier when you zoom in to digitize. So you get the real representation and not outside the boundary line. So this is digitization. This is what digitization looks like. This is what we've been explaining, and this is how to go about it where you want to digitize or trace a feature of your interest. So it's just one click. You don't double click, only when you're done. And if you double click here, the polygon you are seeing shaded will be all that would be captured in your visualization. So let me speed up a little. It's time consuming because you need to show the true representation of feature that's of interest to you or that you want to portray, want to work on, depending on what your user case is. So I double clicked at that point because I just wanted to hurry. And you see, when you double click, this is what it shows you. This is already a feature. And here you go. So if you open this Kaduna map, you open the attributes, you realize that you have shape, polygon, ID, nothing. We can go ahead and add other attributes here, depending on what we want. And that will be what we'll be working on in our next class. So we can go ahead and continue digitizing so that we have more than one feature. Like I said, we're going to be dealing with the Wari and Giwa, Benin Kebi, and So next, I'll start digitizing from here. If you make a mistake, you right click on the last point and you delete the vertex, right? That's very important. I'm happy that popped up. I've told you, you put on your snapping tools, either the edge snapping or the vertex snapping. What that does is that it makes you pick the last vertices without overlaps or gaps. And then when you want to create your feature, very important, you come down here, you click auto complete polygon. If you don't click it, you would have difficulty getting polygon that doesn't overlap. Now let me give you an instance of auto complete polygon that you understand. So like I said, this is the tutorial, so try to show you the mistakes, the errors that bound to happen, as well as you see, that's shown you when you click here, it completes the polygon automatically as long as you started from the edges. It completes it, so you don't need to continue like this. That's what I was looking for when I made mistake. I would have shown you. Okay, let me use this one to show you if you want to digitize this and you don't use auto complete polygon. Polygon, if you just use polygon and you want to digitize, let's say this place from here to here, let me just show you what happens. If you do this, see what happens. There is a gap. So very important. That's a mistake that people make. So I think no, delete this. Delete vertex. I said we were going to be doing 3 polygons. Chukum is the last polygon. But let me just use area because I was just for academic purposes. Photo complete. You see there's a little gap there. That changes everything. Little gap there, that changes everything. So please always zoom in. Zoom in is very important and create as many vertices you can create. Accuracy. So yeah, this is what we have. We have the 3 different. You see from here, you can even start symbolizing them, making them poodle. But what you have now doesn't have uh, any attributes. So this is the map. Let's say this is the. Oh, sorry. I need to. Yes, very important. You need to also save your edit. Save edit. Stop edit. Yeah. So this is what we've got. Um, this is also specially referenced. So it's very important that we understand um, digitizing as well as um, georeferencing. So there are also other forms of um, digitizing tools that you can use. We have, well, this is just the basics. With this, you can digitize every polygon that you see. If you want to do for line, you just come here, create another sheet file for line. Yeah, go through the same procedures you went through. Give it a name, if it's a road, if it's a river, yeah, then this will change to line, polyline, and then coordinate system, GCS as well. And point, the same thing, the same method, and you have map. The next thing you'll be doing is to save the edits which you've done, and always save your edits to avoid that to avoid data loss. Because in digitizing, you may just be digitizing and realize that you open the map and it's nowhere to be found. So very important. Georeferencing and digitizing are essential in real GIS projects. They allow us to convert paper maps, field sketches, and scanned images into analyzable GIS datasets. Example, land administration, environmental mapping, utility planning, urban development. Also very important that we add attributes to this particular map. If you click on it, you realize that the attributes are empty, which is actually what we'll be dealing with in the next class. So here you can add fields. You write the name of the field here, you know, if it's just names of local governments, name, and you have short integer. This is very important. long integer float to double text state. We'll be talking about that in the next class. So spatial data becomes more useful when linked to descriptive attributes, just like this. So this is what georeferencing and digitizing entails. Um, Today, we learned what georeferencing is, adding control points, measuring residual accuracy, updating georeferencing, creating shapefiles, digitizing points, lines, and polygons, editing spatial features, adding attributes, saving GIS edits. You have now taken one of the biggest steps in practical GIS workflow. In the next class, we'll move into attribute editing and spatial query for deeper analysis. If you have questions, drop them in the comments below. Don't forget to like, subscribe, and turn on notifications. See you in the next class. Bye.